Hey everybody, one quick thing. So I'm making this video for project number one. To get started though, I wanted to show this picture, okay? And I kind of wanted to introduce what we're going to go over a little bit. So really quickly, as you see this, here is a bottle that this guy has grown for 50 years, okay? So 50 years. This thing's been going. He has not untapped it, so you can see that little plug up at the top. This thing has been sealed for 50 years. He planted this. He put this thing together. It's just a glass jar. He probably put some dirt in there and a couple seeds, and has let it grow for 50 years. Okay, and you can see this. What I want you to do as you're looking at this, what are some notices and wonders that you see? So I'll give you guys a second to think about that. What are some notices? What are some wonders? Now you can pause the video and think about that if you'd like. I'm going to keep going though. So some of the notices that you might have come up with are, man, here we got a plant that's growing in there. It looks healthy. It's green. It looks like there's a lot of other things growing maybe up there in the top. I'm noticing a lot of roots in the soil. And some wonders that I have are, how does a plant stay healthy for 50 years? I mean, let's be honest. We know that plants use photosynthesis to live, to survive. So another wonder that I have is, how is this plant getting all the nutrients it needs to survive? How is it getting the carbon dioxide, right? Because we know that we know that in photosynthesis, carbon dioxide is a necessity, is a reactant of photosynthesis. But this thing's a sealed container. It's not like it can pull out more carbon dioxide from the air. So these are some different wonders that I have when I look at this. I want to show you another one, okay? So here's a different example of very similar type of situation that that guy grew. This is showing what these are called ecospheres. They're shrimp in here. Now this thing is a sealed glass little jar. Nothing can go into it. Nothing can come out. And these shrimp they've been living for 12 years and are still living and thriving very well. Some questions I have are, how the heck does this happen, right? So to start this out, you guys, these are examples of models, okay? In your workbook, the one right before project number one, it goes into statistics and it goes into modeling. I wanted to introduce this to you guys because throughout science, we will use statistics and models to really test some variables. Okay, and I'm sure you've read through this, and I'm not going to go through it very in depth with you, but throughout this, you're going to see it talk about the average, the distribution, probability, and how to calculate probability. It's going to go into other things such as risk and things like that. And then models, right? So you guys, throughout science, we, especially in science classes and stuff like that, we look for models that we can use. And even in other parts of science, in that scientists, we need models to show the science behind it, okay? These different examples right here are models, right? So here's a model of an ecosystem, right? We have plants in there that's growing, and we can really test some things here. If we had the material, we could test and see how this ecosystem is thriving and how the heck it grows on its own, right? But you guys, this is a model of Earth right here. Earth, things cannot enter or leave our atmosphere. There are a few things like asteroids and stuff like that that do come in and come and stuff like that, you know, and I'm not very terminology savvy when it comes to that kind of stuff. I probably used asteroid wrong. But anyways, the key thing is here, this is a model of Earth. and we can test and learn about how Earth works. And I feel like this follows through with our project, because what we're going to be doing in this project number 1 is we're actually going to make a model of the water cycle. And I want to just introduce this. So we have different types. We have physical models and graphical models, conceptual models that can be used, mathematical models, which I really love to use these in the science that I've done, and in my class that I teach in Rigby, we use a lot of those. So you guys, I want you to just understand what models are. So to get started for this project, so I hope, first of all, I hope that answered your question, or helped you understand why models are so important and why these labs and projects that we'll do in this class are key. Okay. So to get started, here's project number 1. This has 2 parts to it. The first part's in lesson 2, and the other part is in lesson 4. This first part is going to go over the water cycle. Here's another model of the water cycle. This is a pictorial model that I wanted to go over, a graphical model, I guess we could call it, showing the different parts of the water cycle. Now, I bet you've never learned the water cycle in this grade of detail, but it's really important that we understand this part, right? So we have transpiration that comes from the plants. We have water molecules in the air that get transported to other locations. They can condense and fly down and then come down as precipitation. We also have sublimation, deposition, runoff, evaporation from lakes or ponds and oceans, and that kind of thing. So we have condensation in the air, all that stuff that we've kind of learned about. But there's some key parts that we don't really think about, such as infiltration, sublimation, percolation, plant uptake, and groundwater. Okay, so these are all parts of the water cycle. We're going to really look at, and so take a look at this and use this, because there will be questions after the lab for part 1, so in lesson 2, that you will need to answer, and hopefully this will help you understand those type of things. I will also put a link to this in my page with this video that you can refer to, okay, because I really think these guys really went into great detail. The National Oceanic and Atmospheric Administration really did a great job going into this in great detail. Okay, so you can use this as a reference. So what you're going to do here for this first lab, and I'm going to turn on my camera if I can figure out how to make this work. And I'm just going to model this for you to show you a little bit. And you're in my kitchen. It's going to be kind of messy. I would have done it in my lab room, but I wanted to show you how easy this can be done in the home, since this is where you guys will be working at and doing this lab. And it's really important that you guys do these labs, because you're in a science class and there's skills that you need to be able to model and show. So let's see if I can make this work. All right, here we go. You guys, welcome. And I'm going to put this in as a question, I guess. I'm wearing my Aggie sweatshirt. I'm a Utah State Aggie fan. They're my favorite school. That's where I went to school and got my bachelor's degree, and I'm actually getting my master's degree finished here in the end of this month in April through Clemson University in biology. So I really love biology, you guys. I love environmental science, and I'm really excited about this. So anyways, that'll be a test question that you guys can get some freebie points for, I guess. All right. So let's go over this real fast. So it says here, right here, it has the materials that you'll need: water, 2 pots with lids, a heating source, measuring cup, gloves, and apron. And you know what? Gloves and apron and goggles. I mean, if you guys want it and look really official, you can do that. But we're just messing with water and some measuring cups. So right here, it tells us the information that we'll need. So measure out a cup of water and pour it into its first pot. And so let's do this. Okay, let me see if I can get this to work. Okay, so here I got some 2 pans, and hopefully this will work. I wish there was a way to make the, oh, you know what? I think can I make this bigger? Working on my end. I just wonder if it's working on your end. Open that back up. Okay, I'm hoping, I'm going to watch this video afterwards, and I'm hoping it's zooming in on my camera, but we will see, okay? Anyways, what we have here is a pot. You'll need a lid for it, and actually you're going to need 2 lids, and I've got just another pot here, okay? So it says to put some water into the first pan, and let me refer and see how much water it was. So it says to put a quart of water, okay? So I'll let you guys do those kind of measurements there for that. I'm not going to go through this entire lab just because it's going to take way too long, but you would put a quart of water in this first pan, and you're going to heat it up, okay? Heat it up not very much, probably just to a, just on medium maybe, or medium low is what I'd probably do, and you just want to get this thing going. And as this is going, you're going to keep this lid on. And every so often, what you're going to do is you're going to get some water collecting on top of this lid. You're going to take that, you're going to tap it into this other pan that should also have a lid on it to seal it off. And you're going to put that back on, and you're going to do that several times. I think it says to do it 4 times. And after that point, I want you to measure how much water is in this container. Okay? Now, you're in science class, and I'm going to tell you, I'm going to dock you, I'm going to make you do it again. If you can't, if you don't have actual data to put there, okay? So, yeah, it says right here, after a few minutes, I'll let you guys determine how much that is, but make it consistent through each time, right? We want to have as least amount of variables as possible in your experiment. So, if you're going to do it, maybe do it for 2 minutes, okay? 3 minutes, and every 3 minutes, that's what you're going to do to get that data, okay? And you're going to tap that on there like it says right there, get the drips off, put it in there, and repeat that 4 times, okay? What I want you to do is measure out that material, and I want you to keep track of how much the water that was left in that pot, the second pot. Then after that, you'll just pour it back into the first pot again and measure that as well. So you can start making some hypotheses. How much water do you think is going to be in this little pan, right? The one that we're collecting the water in. And then after you dump it back into this container, what do you think is going to happen? Is it going to be the same amount of water? And I wonder why. Okay, will it change? So think about that and make some hypotheses based on that data. Okay? All right. After you get that done with that, I'm going to turn off my camera again for a second. Let's go. There will be some questions that you'll need to answer. Okay? I'm going to go straight to that. And hopefully I've been able to answer most of those questions. All right. So right here, let's look at those questions very briefly. There's 3 of them that you need to answer for lesson 2. The first one is just matching, so you can refer back to that document that has that model, that picture model that you can use. Okay, and you're going to tie the parts of the water cycle to what you saw in the cups or in our lab. Okay, now you can see these key questions here. How did the amount of water put into the beginning compare to the amount of water that was left in the pot after the process was complete? So these ones, you guys, I need some numerical data. Tell me exactly what was in there before, what was in there after. How did it change? And when it says explain, you need to be able to explain your answer. And how I do this, I will have a video in here as well to share in a separate part on how to write in discussions. But you guys, discussions have to be written in a CER, is what I like to call it, claim, evidence, reasoning, paragraph format. And the same with these labs. If it ever says explain your answer, you better have a claim, you better have evidence, and you need to explain how that evidence supports your claim with reasoning, okay? And so that's what I want you to do with these questions. Make sure you have some real life data in there to support. In what ways was the procedures that you perform in the lab a model for what happens in nature? Okay, so back to that thing about a model. What is a model? How does this model what happens in real life nature with the water cycle? How is it similar? How is it different? It's not going to be the exact same, but there are some similarities and differences there. Okay? All right, you guys, that is the first part of this lab. Let's go to the second part. The second part is also a type of lab, and it's fairly straightforward, and I'll walk through it with you. As this loads up, let me pull it up for us here. So like I said, this is the second part is in lesson 4, right here. Hands-on lab instruction, okay? And you can always refer when you get down to lesson 4. Go ahead and come back and watch this video if you need to, okay? So for this one, you guys, what you're gonna be looking at is hydrothermal vents and stuff like that, okay? Now I'm just gonna walk very briefly through this with you guys. But basically what you're gonna have is a large glass container and one small bottle with some food coloring, water, and some string, okay? Now these procedures are fairly straightforward, and I'm gonna put a picture of these in this page as well so you can refer to them. But what you're gonna do is you're gonna fill the large glass container with cold water and make sure it's kind of cold, okay? And then what you're going to do, so one way that you can get this cold is fill it up with water, put some ice in, let that ice completely dissolve and melt, okay? Because we don't want ice parts in there, but we do want it cold. The colder, the more drastic this lab is going to be. Then what you're going to do is you're going to tie one end of the string around the small bottle, fill the small bottle with hot water, okay? So fill this one up with completely hot water, and you're going to add a few drops of food coloring to the water, okay? So and I would add it to the water inside of the bottle, okay? Now you're going to keep the small bottle upright, and then when you lower it into the cold water glass container, water is going to start leaving the little water bottle that's full of hot water out into the cold water, okay? And you've got now food coloring inside of that. And so you can see how hot water and cold water will interact and what's going to happen. You guys make some key observations of what happens, okay? Because you'll need that for the lab. So I think this is a pretty straightforward lab, so I didn't want to walk through that with you because it's hard to do it and not just video it. And maybe I do need to just do a video of it. Maybe you guys can give me some feedback of if you'd like me to do a demonstration of this, but I think it's kind of fun just to do it and try it out. So for this one, there will be some questions that you'll need to answer afterwards. Actually, I'm going to do that, you guys. Part of the video, or my quiz at the end, I want you to give me a survey of what you think. That'll be one of the other questions. I want you to tell me if you think I should go through each of these labs in real life, or if it's better that I don't. Okay, so I want your honest opinion on that. There will just be, you will get points by just giving me your feedback, okay, and your opinion. Okay, let me go to the project. Okay, so for this one, there's also, let me scroll down, 3 questions, okay? Describe the purpose of the lab and the procedures you followed. So tell me, what was the purpose of this lab? And I kind of talked about it before. It's about hydrothermal vents, but go into more detail and not just say it's because we're learning about hydrothermal vents. No, tell me exactly what the lab kind of models for us, okay? And why is it important that we follow the procedures that we did? Why did we want the food coloring in the hot water and not the cold water? Okay, which one moves more and why does it move? Think of kinetic energy there. Describe what happens to your experiment. Okay, so this one, describe, tell me, just give me some great detail of what you observed. Analyze what your results mean. Did you conclude from the results of the experiment? What did you conclude? Okay, and that'll be it. So I hope you guys don't have any other questions. If you do, please email me or get a hold of me in Google Hangouts. We can also, if we need to, I can definitely go over this, do this lab for you and you guys can just observe that way too. But I think it's fun that you guys get that hands-on aspect. Anyways, answer those questions in the quiz for full points, and I'll be talking to you in here soon, next unit.